My name is Bret Stateham. I'm a Microsoft technical evangelist, actually based in San Diego, California, in the US of A. But today I'm actually sitting in an office at the Microsoft MTC, the Microsoft Technology Center in Southfield, Michigan, just outside of Detroit. So I kind of brought along some stuff to demo with here. I was traveling for some other business and I'm doing my virtual session from there. So kind of nice to be able to do that. With that said, let me jump back to the slides here. And so like I said, my name is Bret Stateham. I'm a technical evangelist, and that means that I really am just sort of focused on helping developers understand Microsoft sort of developer-related technologies. So I do a lot with Azure. Azure is a gigantic cloud platform that has a ton of different offerings, but I tend to mostly focus in on the Internet of Things and services around that. And so what I was going to talk to you about today was an offering that we have called Azure IoT Edge, which used to be called the Azure IoT Gateway SDK. We kind of rebranded it to Azure IoT Edge. And look at how you could set that up with the current shipping bits on a machine like an Intel NUC. So Intel and Microsoft partnered recently on a Intel NUC, and along with the Grove sensor kit and Arduino 101, a bunch of other cool stuff that you can play around with. But the NUC is a pretty handy little box. It's Atom processor in it. We run a Wind River Linux on it. It's got BLE and Wi-Fi and Ethernet and USB. And so you can use that to connect up to the devices in the field and be able to create a gateway device to help sort of proxy that device messaging up to the cloud. So that's what I'm going to go through today. I'll start out just sort of looking at the Microsoft Azure IoT Stack, see what sort of technologies we use, and really look at the heart of Azure IoT's stack, which is called Azure IoT Hubs. Then we're going to come back in and take a look specifically at this IoT Edge offering that you can install and set up on a device like an Intel NUC. And we're at that sort of unfortunate point in the history of products where we're on the cusp of a version change. So what I'm talking about today is IoT Edge V1, I'll call it. We should have a public preview coming on IoT Edge V2. I'm sort of hoping before the end of the year. I'm not on the product team, so I don't speak for them. That's just kind of what we've been told publicly. So sort of hoping that we'll get to see some new preview bits before the end of the year. And what I'll do at the end of the session is just sort of talk about some of the differences that you may look forward to with the changes coming in V2. So with that, let me first jump in and take a look at sort of the Microsoft Azure IoT Stack. So if you haven't had a chance to look at Microsoft Azure yet, it's Microsoft's cloud platform. And so it's certainly a place where you could go spin up virtual machines and, create web applications and store data in databases and all that kind of stuff. But we also have a large number of targeted services towards specific use cases. And so IoT is certainly one of those specific use cases. And so at the heart of Microsoft's Azure IoT offerings is a service called Microsoft Azure IoT Hubs. And in fact, IoT Hubs is not a recent offering. It's actually been around for, I think, a couple of years now at this point. But it's one of many messaging technologies we've had available in Azure. So in Azure, we go back to sort of the earlier messaging technologies. We had a very simple in and out messaging queue in our Azure storage service, which is really easy if you just need an easy queuing service. What I call a first in, first out, style queue. And we have Azure Service Bus, which gives you a much more mature and robust set of APIs and queuing technologies, but with some of that development overhead of having to deal with more complex SDKs and things like that as you work with those. We also had another service that's very popular in IoT scenarios and telemetry type scenarios called Event Hubs. And Event Hubs is a service that's built around or that's targeted at high volume message ingestion. We want to be able to get millions of messages in per second, let's say. And so that's really cool if we're looking at getting a lot of data in. But the problem that Event Hubs has in an IoT device-specific scenario is that, one, it's unidirectional. So yes, I can get messages from a device, as an example, but I don't have a way to send a message back down the channel to the device, right? So I don't get bidirectional communication with an Event Hub. We also have an issue around the credentials for each individual connector. So if I want every device to be able to connect as its own identity so that I can manage it and secure it, et cetera, as an individual device, Event Hubs didn't really have a supported model for that. So Azure IoT Hubs is really that answer. Azure IoT Hubs gives us a device registry so we can create a secure device identity for every device that we want to be able to communicate with our Azure IoT Hub. We also get device configuration. We can store configuration for that device in the cloud, and then when the device checks in, it can download that new desired configuration, make it so, and then also report back up what its actual configuration is. We have the ability to expose methods on the device in code and call those methods down through that back channel through the IoT Hub. And of course, the device has the ability to send data up as itself for us to consume. And so we're going to have these devices in the field, right? And on the slide, I kind of made it look like an Arduino, but this could be any kind of microcontroller. Really, we're not so typically often concerned about the microcontroller itself, but rather the things that are connected to it, right? The sensors, the data that we want to be able to collect is typically coming in through some kinds of sensors. And we may have actuators or things that we'd like to be able to activate through that device, like turning on a motor or controlling the lights or, managing the environment, with the HVAC systems or something like that, right? So the microcontrollers are out there. They know how to control and sense the environment that they're in. And so what they're going to do is communicate with an Azure IoT Hub using some standard protocols. And so we have based Azure IoT Hubs on a number of industry standard protocols: MQPS, MQTTS, and HTTPS. And I'm always very specific to add the S onto the end of those protocol names because they indicate that there's a secure layer required in those. We don't allow insecure communication with Azure IoT Hubs. We're going to require that secure communication. And that's important because that places a requirement on the device that you may not always be able to meet and might have a need for an intermediate solution. So anyhow, once those devices send their messages up into the IoT Hubs, those messages sit there and are available to be consumed by one or more readers on the back end, right? So those other back end services could be, really any other Microsoft Azure service, or what the heck, don't even have to be Azure. They could be on-premises code running, in your own data centers that are consuming messages out of the Azure IoT Hub up in the cloud. So those could be virtual machines. They could be data getting pushed into databases. We might be using machine learning or other AI cognitive services type things on top of that data, pushing the data into reporting platforms like Power BI. The list goes on. And so the way those back-end services consume the messages in our Azure IoT Hub is through a set of open APIs and SDKs that are published. We have SDKs to get messages out of IoT Hubs with .NET, with Node.js, with Java, with Python, with PHP, whatever. So a wide array of language-specific APIs to help you consume those, or worst case, just through some standard REST APIs to be able to consume those messages. So that's sort of the overall view of what IoT Hub's role is in the Microsoft Azure IoT Stack. And so if I look at this slide, this is really sort of, in fact, a somewhat dated view of the breadth of the platform that's up in Azure. But if I focus in down here, that's the IoT Hub service, right? And as I said, that's sort of the heart of our Azure IoT service. And I can certainly, once I get messages into the Azure IoT Hub, get access off to all these other sort of services that are related to analytics and IoT. We have services like Stream Analytics that can process the stream of messages coming in and redirect them or do different types of analysis on them. We can go to event hubs and machine learning and a whole bunch of other cool stuff. But once you get your messages up into Azure IoT Hubs, not only are those services available, but really sort of the whole breadth of Azure now just becomes available to you. And it's now all of a sudden just another way to get data into your application architectures. So it's really cool, super powerful to be able to get that data in and through a variety of mechanisms, get it off into other services out there. So I only have a single monitor here. So I'm going to go ahead and just really quick jump back over to the screen here. Cool. Make sure I didn't see any warnings in the chat window or anything like that. Wanted to make sure you guys are able to hear me and see me okay. Cool. All right. So with that, I'm going to go ahead and continue on. So IoT hubs, really cool stuff. If you're a developer out there, you're interested in playing around with microcontrollers and sensors and all that, or maybe not playing, maybe that's the wrong word, actually building production solutions that participate in sort of this grand new world of IoT. You can learn all about Microsoft's Azure IoT hubs up on the documentation there. There's a free usage tier that gives you a way to play around with having some devices publish up, just so you can get a feel for how the SDKs work and all that kind of stuff without actually incurring any costs. And you can learn all about that using the link there on the screen. That's sort of the Azure IoT Stack. And like I said, at the heart of it is Azure IoT hubs, but then we have this whole other family of services up in Azure that we can use to consume those messages and to be able to communicate with devices via the Azure IoT hub. One of the next problems that you typically run into as you go out and implement IoT solutions in production environments or in a variety of different sort of distributed environments is the need for some more compute processing at the edge. And that could be for a number of reasons. And so I want to jump in and take a look at our offering called Azure IoT Edge. And again, I'm sort of tagging this as V1. It's the currently shipping bits that we have around this. This was previously available as an SDK called the Azure IoT Gateway SDK. And again, with the Build conference last year, we sort of rebranded it off to Azure IoT Edge. And that's the name we're going with continuing forward here. So the reason we need a device or an edge at the device, or some sort of a gateway at the edge. There, I'll get the words out right. The reason we need it actually is manifold. There's a lot of reasons why we might want a computer sitting out closer to the devices. And so one of the first reasons may be that not every device has the ability to connect to the internet. So on the slide there, I've got a picture of a cool little reference design from Texas Instruments called the sensor tag. And in fact, if I jump over here to my camera, you'll notice I've got a couple of them sitting over here. And so this is a TI sensor tag, and it comes in this cool little rubberized package. I've stuck a couple of zip ties on there because I have two of them, and this is how I sort of visually tell the difference between them, because otherwise they look identical without something on there. But so this is just a little TI sensor tag. You'll notice there's a little button here on the side. There's a button over here. There's actually a Hall effect or a magnetic read switch in there. There's LEDs on the back, sort of down here inside this little slot. There's a buzzer. We have an accelerometer and a magnetometer, so it can tell tilt. It's got a light sensor, temperature and humidity, and all that cool stuff sort of built into this little guy. But the way that it communicates with the rest of the world is through BLE. Right? It doesn't have built-in Wi-Fi capabilities. Now, TI sells other boards that do, but this particular one just has BLE. So that's Bluetooth low energy. And so I need to be able to communicate with it using BLE. And the other thing is that BLE doesn't have a TCP/IP stack on it, right? It doesn't have the ability to take all this cool sensor data and then start pushing that directly up over the internet to a service like Azure IoT Hubs, right? So by the way, I have another one of those sitting here. If you were to take all the rubberized packaging off and the plastic case and all that kind of stuff, this is one of those TI sensor tags. See if I can get it to focus there for you. Of course, it's not going to. There we go. Cool. So this is the little guy, and it's, you can see it's BLE, and just a cool little board. You can play around with them. You can actually deploy custom code to them if you want to. You can jump up to learn more about those if you're interested in them. But just a cool little reference board to be able to play around with and not have to go build, hardware. They've already built it for you, right? So that's kind of the cool part there. So anyhow, if I want to be able to use this and get the sensor data off and up into the cloud, I need something between this guy and the cloud. And so that's where a field device like this guy, the Intel NUC, or another gateway device comes in handy. So in this case, this is the Intel NUC. It's just an Atom processor machine. It's got Wind River Linux running on it. It's got USB ports and Wi-Fi and a whole bunch of other cool stuff on it. And so I can use this as a way to talk BLE to this sensor tag or multiple sensor tags over BLE, package that data up, and then communicate off to Azure on the behalf of that device, sort of impersonating that device. And we'll see sort of how we get to that configuration. So that's one of the first reasons, is that not every device has the ability to connect, from a protocol type perspective. The other reason why you might need to do it, and this goes back to me talking about the MQPS and MQTTS and HTTPS, those secure requirements for the communication layers, is that some of the microcontrollers that we often work with, as an example, the ever popular Arduino Uno, don't have the processing oomph to do the TLS and SSL cryptographic stuff that's required for the TLS and SSL, right? So this processor that's on here just can't handle it. And so it could be that if you've got legacy devices, or if you're building new devices and you've just decided you want to go low power, or with a lower capable chip, then it's not going to be able to do, even if you stuck an Ethernet shield on this, the security requirements can't be met by that chip, right? So that might be another reason why you can't do it. Now, the third reason, and I didn't actually stick a slide in here for it, but we'll talk about it a little bit more when we look at V2, is that we might want to start to deploy some of the pre-processing or some of the analytics that we want to do on that data closer to the edge, closer to the device, right? And so as an example, if I jump back over here, imagine that this wasn't just a sensor. Let's say that this was a motor and it was cutting on something, and it starts to report back to the NUC sort of performance telemetry about that. And if I discover that the motor is having a problem and it's in the middle of interacting with a human or cutting apart or something like that, and it has to round trip all the way up to the cloud to let me know that there's a problem, it could be that I've already caused damage before I can send a message back down to the device telling it to turn the motor off, right? So being able to have sort of that analytics running on the device or on the edge, not having to round trip all the way up to the cloud to get that analytics done, can help cut down that latency and that round trip time, and possibly save me from damaging either the thing that this is working with or the thing itself, right? So there's often a desire to have some analytics on the edge. And so our V2 scenario makes that more possible. You can do it now with V1, but V2 simplifies that. All right, so field gateways then are sort of the solution here to a lot of those problems, right? So we've got our devices in the field. It could be one or many of those devices. We've got our IoT hub up in Azure, and we want to be able to communicate from those devices and back and forth with the Azure IoT hub. And so it's the field gateway that sits in the middle of that, right? So like this Intel NUC. And so the field gateway will use local protocols, like maybe serial over USB or Bluetooth low energy, or LoRaWAN or RF or Wi-Fi or whatever, to communicate with the devices locally, and then turn around and use those protocols I talked about earlier, MQPS, MQTTS, and HTTPS, to communicate on those devices' behalf with the IoT hub up in the cloud. So the pattern here is that, again, we've got things sitting out there. We've got insights that we want to gain from those things. We've got actions that we want to take based on those insights, right? So things like, hey, the motor's getting out of performance. It might cause damage. That might be an insight. The action would be, okay, well, then go tell the motor to turn off. And so those typically are running up in the cloud. And so we could have the things pushing directly into those through some custom APIs and all that kind of stuff. But that's likely going to require a pretty heavy engineering effort to be able to scale and be secure. And so, we could sort of build that custom, or we could put something like Azure IoT hubs in the middle there to simplify that communication for us and standardize it across all different types of things and all around the world. So if we add edge into that, right, instead of having to round trip all the way through there, those insights and those actions closer down to the things themselves on some sort of an edge platform to reduce that amount of round trip latency that has to occur. And then only when we need to send data up to the cloud do we do that. So that can help save costs and bandwidth and a whole bunch of other cool stuff. All right, so what runs on the gateway? Azure IoT Edge is what runs on the gateway. And so you can get the current shipping bits for Azure IoT Edge from GitHub. This is all open source. It's up at github.com, whack Azure, whack IoT Edge. And there's also, so in fact, what you get with this, in fact, let me go follow that link there. All right, so what's inside this repo? Looks like my page doesn't want to load that fast there, but okay. But this is that repo, and it's a whole bunch of, like, if I came in here to like core and drilled down into source, here's the gateway core code, right? And you'll notice it's a whole bunch of ANSI 99C or ANSI C99, I should say, compatible C++ code and stuff, right? And so if you're a C++ dev, it could be that you're looking at this going, hey, this is awesome, cool. And you can certainly clone this repo. And then if I go back up a couple levels, we'll talk about modules and things like that coming up here in a minute, but you'll notice the source code for all the modules that I can plug in here, like BLE communication or talking to the IoT hub and all that kind of stuff. Those are all there, and you can either write your own or modify the ones that are there or whatever, right? So it's very extensible, but the core SDK in V1 is written in ANSI C99. And it's going to require that you go in and build it for the platform where you run it, right? So, for example, on the Intel NUC, I'd have to go make sure that I had the build tools installed, and then I could go in and download the source code and then compile it, et cetera. Or hopefully somebody else has pre-built it for my platform, and then I can just download that pre-built. The other thing, though, is that these modules that I'm talking about up here don't have to be written in ANSI C99. We also have what we call loaders, and those loaders support different runtimes. So we have loaders for .NET Full Framework, we have loaders for .NET Core, loaders for Node.js, loaders for Java. And so if you want to write your module in a language that you're more comfortable with, but still, use the core gateway SDK, you can certainly do that. However, to simplify your life, the team has gone ahead and built some pre-built packages for those different development environments, right? So, for example, if you're a Node.js developer, you can just do an npm install and pull down that pre-built SDK for your platform, and then go out and run it without having to compile it, and then you can write your modules in Node.js and all that good stuff. So it makes that much easier. So you can learn more about language-specific packages at that URL. All right, so let's talk a little more specifically about what makes up a gateway, right? So the gateway runtime itself is really this lower big blue box on this slide. And so what the gateway runtime is responsible for providing is a messaging broker, a way for modules to be able to send and receive messages from other modules. And so this internal message broker in V1 is implemented using a messaging library called NanoMessage. And so it spins up this NanoMessage broker and then allows the other modules to receive or publish messages into that broker. The other thing that the Gateway Runtime SDK itself, or Gateway Runtime itself, supports then is the configuration of which modules you want to load, which modules communicate with other modules, and how it should go about loading those modules. So when we run it, we're going to give this guy down here a configuration file that tells it, here's the modules I want you to use, and we'll give them paths off to where the binaries are that implements those modules. We'll give them configurations for those modules. So for example, the logger, it most likely is going to log to a text file. Well, where's that file? We get to tell it what's the path, right? So we can pass that configuration into that logger, et cetera. So the gateway itself is really just that message broker, and then sort of that engine for spinning those modules up, getting them loaded, getting their communications wired up, and then letting everything run. So this is a simple gateway configuration where I have two modules. One of them is a hello world module that does nothing but publish a message into the broker every 5 seconds that just says hello world. And then we have another module that does nothing but receive any messages that come to it and dump them out to a text file, right? So in fact, in this simple configuration, there's no IoT, there's no device. This is just two modules communicating with each other down here on my gateway. Right. So if I want to actually show you that, remember on my camera here, I mentioned that I've got this Intel NUC over here. It's running. I've got it powered on, and I've ahead of time gone ahead and done some configuration here. And in this case, I'm SSH'd into it. Right. So the IP address of this on my local network is somewhere in here. Cool. So this is its IP address, 10.0 to, or 10.8.201.162. So I'm SSH'd into that box, and I just logged in as root. And so if I were to go to USR share folder on this box, you'll notice that I have a folder in there, and this is part of the setup for the SDK, but it's called Azure IoT Edge. Right? And so the way that this got installed for me on this NUC is that I followed along with the instructions, and the links to it are in the slides. In fact, if I jump back to the deck really quick, I should have advanced to the next slide. Right, this URL right down here, there's one up here that to doing a similar thing on Raspberry Pi. This second link down here specifically for setting up the NUC to run the Azure IoT Edge gateway. And so you can, if you want, follow that link, and here's all the instructions that you would walk through to go get it set up, and this walks you through setting up that Hello World sample that I'm about to go through, right? But basically, you're going to go do a number of statements, and then when you get down here, I can then go change into that folder, that USR share Azure IoT Gateway SDK. Remember I said it's Azure IoT Edge now, but that's where I'm at back over here. And then, so I'll cd Azure IoT Edge. And if I look in there, there's that samples folder. If I look in there, you'll notice a number of samples. So I have ones that are the Hello World. I have a sample that'll help me simulate devices and actually push data up to the cloud. We'll see that in a minute. And then I have a BLE one that'll actually talk to that sensor tag over BLE and publish that data up to the cloud there for me. So let me jump back here then and go into the Hello World. And if I look in there, you'll notice there's just two files. One is the actual gateway bootstrapper. So this spins up the gateway. And when you run it, you point it off to this configuration file. So here's this hello world or hello_world.json file. And in fact, I think, did I already have that open? Yeah, so I've got a copy of those files over here. It's just they're a little bit easier to look at than through an SSH session, but this is that hello world config. And so you'll notice it's a JSON file, and inside the JSON file, I have a collection of modules, and then I have links that set up how those modules communicate. So that's pretty much it. Inside there, I tell it, here's the two modules. I'm going to have one that knows how to go in and log everything. And then I have another one that's just that hello world that just spits out, a hello world message every so often. So those are my two modules, right? And so then, and then here's the actual paths off to where the actual libraries that implement those modules are at. If I come down here to the links, I say any messages that are sourced or come out of hello world go into or have logger as a sink. Right, so we take message from hello world and we send them into logger, and that's it. That's my configuration. So now if I go back here to my SSH session and LS, notice there's not currently a log file sitting out there. So in fact, if I go back to the here again, notice that the configure on the logger, we passed in these arguments, and here we're telling it, hey, dump your log into this file called log.txt. So if I run this, so I'll tell it to run the hello world with that hello world.json configuration file. And so I get this wonderful message that says, great, we successfully created the gateway. It's going to run until you press enter. All right, so I'll press enter and it should stop. All right, really impressive, right? But if I look in the folder now, I should see this log.txt. And if I actually go look inside that file, you can see that, in fact, it was spitting out hello world messages periodically, right? So there's a number of hello world messages coming out into that log file. And then if I were to remove that log file and rerun the gateway again, let it run for a few seconds here. We'll let it go a little bit longer this time. All right, let's see what happens there. Cat log.txt. All right, well, maybe I didn't let it run any longer, but okay, same thing. So it just recreated the file. So there it is, it's working, cool. So that's sort of the basic, if you get that, you sort of understand the basic mechanics of the gateway. So at this point, let me go step that up to something a little more involved. I'm gonna do a simulated device gateway. And so at this point, I actually wanna go start sending messages up to an IoT hub. So you'll notice I have a lot more modules here. I'm going to pull in 2 simulated devices or 2 instances of the simulated device module with different configurations. One that acts as a device with this MAC address, accidentally wrapped, and another one that acts as a device with that MAC address. We'll map them up to actual device IDs in the hub and then send those messages off to the hub. And then we'll also log all the messages out to a file. So if I go back to the configuration, well, let's actually first jump into my portal. So this is the Azure Portal. This is, and in fact, if you have an Azure subscription, it's just HTTPS portal.azure.com, get you up there. And so I have this set up here already with the services that I'm going to use in this lab up here on the screen. You'll notice I have an IoT hub. I have a service bus namespace, and then I've got some Azure functions we're going to come back and see in a little bit. But if I open up that IoT hub, this is the configuration of that hub. And if I come down here, remember I said one of the cool things about IoT hubs is that we get this device registry where we can tell it about the individual devices that we want to be able to communicate with. So I'll go to the device explorer here, and you'll see that I already have a number of devices set up. And so I have a couple of them down here. One of them has that MAC address we saw on the slide of, not MAC address, it has an ID, and the ID could be anything. It could be a GUID, it could be a name, Fred, Ethel, it could be my kitchen lamp, I don't know, whatever. I chose to use an ID that looks just like the MAC address that the device is going to act like it has, right? So I have a device ID of 0101010101 and another one 222222, right? Each one of those devices, and by the way, you can click add to make a new one. It's very quick and easy, and you basically just give it the ID. But each device is then also given its own set of credentials, right? So it has 2 versions of its password, these primary keys, right? So you could think of this as its username and this as its password, right? So in order for that device to be able to connect, it needs to know the name of this hub, and it needs to know its ID and its password, right? The reason we have 2 passwords, they both offer the same permissions, is so that you can have the device run using this one for a while and then switch it to using this one and then regenerate the original one, right? So you get these sort of rolling key changes going on here. The connection strings are nothing more than all that information wrapped up into a single string. It tells it, hey, here's the name of the IoT hub, here's my device ID, and here's my password, all wrapped up into one nice semicolon delimited string for me. So anyhow, I want to know those values. And so if I go back over here to the configuration for this simulated device, you'll notice I'm going to have a number more modules here. One of them, though, is the IoT Hub one. This is the one that's actually going to communicate with the IoT Hub for me. And so in order to do that, it needs to know the name of the hub. So there's the name of the hub that we were just looking at back over here in the portal, right? Edge IoT. And if I were to go up and look at the overview for that, we can see that it has a host name that ends in azure-devices.net, right? So that's the globally fully qualified unique DNS name for that IoT hub. So if I know that and that, I can get the FQD in for it. And so those 2 pieces of information are going into my config. There's that full URL. And then remember those protocols, AMQPS, MQTTS, or HTTPS. Here I'm telling it to communicate using the HTTPS. We just don't put the S in here. I wish we did, but we don't. It means HTTPS, though. So then I tell it about my 2 simulated devices. So there's the simulated device module that's pre-written, and all it's going to do is basically spit out a fake, constantly incrementing temperature sensor value. So I think it starts at like a 10, and then it's going to wait 2,000 milliseconds and then send out another one. And here's the MAC address it's going to impersonate, right? And so I tell it to use that module, impersonate this MAC address, and send out a new incrementing temperature sensor value every 2 seconds. And we're just going to name this module SimDev1. I have another instance of the same module, but this time I'm calling it SimDev2. The name doesn't matter. Again, I could call this one, bananas, and this one oranges. It's just a name. But I tell it to act like this MAC address and also to send a message out every 2 seconds. So those are those 2 modules. Then I have a mapping module that says, if you get a message from this MAC address impersonate this device ID. And that's why I named the device ID in the Azure IoT Hub the same name as the physical address, just so it would make sense, right? Again, if I go back to this device explorer, if in the hub I had called this 010100 device something else, let's say I called it pumpernickel as its device ID. I don't know why I would do that, but back over here, I'd say, okay, well, when you see the message, coming from this MAC address, map it up to the ID pumpernickel. And then here's that device's password, right? So notice this one ends in SVG equals. So if I go back over here and look at the device itself, sure enough, SVG equals. There's that primary key we see in there, right? And so the mapping device is just mapping local hardware device IDs to device IDs in the IoT Hub for me. So back over here, it does the same thing for the O2 device. And then finally, I have my logger. Cool. So the linking down here says we're going to send all messages to the logger. Messages coming from the first simulated device go through mapping, so it gets its device ID, and then mapping sends those off to the IoT Hub to be module to be actually shipped up to the cloud. Same, any messages coming from the simulated device 2 go through mapping, and then mapping sends them off to that module to go up to the cloud. It is possible, remember I said we can do bidirectional communication though. So if messages come back from the hub, we'll send them through mapping to reverse map so that we can send messages back down to the simulated device 1 or simulated device 2. So that's that configuration. And so that JSON that you see there is really that, there's a graphical representation of that JSON. Cool? So let me jump back over here. I've already put that configuration down here in my NUC. So we'll change back up into the simulated device folder here. And I'll just, again, if I look in that folder, there's an old log. Let me RM that. Cool. That's the name of the log file that this one is configured to dump to. But so I'll just tell it, okay, run the simulated cloud or device cloud upload and use the simulated device cloud upload JSON that we were just looking at as its configuration. Cool. So this guy's off to the races. And so here I can see those 2 simulated devices and those constantly incrementing sensor values. Now they should actually be going up to the cloud. I'm not getting any errors, so it looks like things are working pretty good. But how do I see them, right? If I go back to the portal and look here on the Edge overview, the IoT Hub overview, I don't see the actual messages themselves. The portal doesn't let me view raw messages. I can get message counts, but this isn't real time. It'll take a few minutes for this to update. So you can refresh it and you'll see that number, that 2552 going up, periodically, but that's not a great way to monitor messages. So remember I said that we can read those messages out using some standard SDKs and stuff. Well, there's a pre-built tool that you can use if you're called Device Explorer. So I'm going to use that one. And you can go search for Device Explorer to learn more about it. There's also a Node.js called IoT Hub Explorer that you can use for this. But with Device Explorer, I can point it up at that same IoT Hub, right? So there's that Edge IoT Hub that we were looking at before, and then the administrative key for it that you get out of the shared access policies here. And now if I go to the data tab, it'll actually go query that hub, and there's all those devices that we saw, and there's those 2 simulated devices. So I can tell it, look at that device and monitor its messages. And so let's get this where we can see both windows. Cool. Let's move it the other way. Notice that, we're getting 27, 28, so 29, 29, 30, 30. So I see those messages actually coming up. It's round tripping. It's actually coming off the NUC, right? So the coming off of this NUC up through the cloud and then down to my laptop through the network here. Cool. So that's sort of that path that's going there. And similarly, remember the device 2 is also sending. I could flip over and tell it to monitor that other device, and I'll see its messages coming in here as well. Pretty cool. All right. So it's now working for me. So those are all simulated devices. I want to get back to actually working with real devices. So that's sort of the next thing that you deal with, in a gateway scenario, is that part of what the gateway is implementing for you is this half of the communication, right? So in the case of my sensor tag, that's BLE. In the case of, if this were a gateway running inside a car, this might be CAN bus or something like that, or Modbus. Or if this was a gateway running on a factory floor, it might be OPC UA or something like that, right? So it kind of depends on what your devices are and what they speak as to what protocols you're going to need to implement support for on your gateway device. But for this demo, we're going to be using BLE. And so if you haven't messed with BLE before, it's kind of its own, unique custom configuration or protocol here. And so a big part of understanding BLE is understanding two of its subprotocols called GAP and GAT. And so you can follow the link there to learn more about what those are. But GAP is the generic access protocol, and it's how BLE devices advertise themselves, and then BLE clients can connect to them. So it's sort of the connection management protocol. And then the GAT is the generic attribute protocol, and it controls what data is traded between these guys. So how do we connect? And then what do we ship back and forth once we're connected, sort of thing. So this guy right here, this sensor tag, this is a beautiful table, is sort of a representation of the sensor data that comes off of this TI sensor tag. And so this all came from TI's documentation on these sensor tags here. And so basically there's a big, long, ugly GUID that represents each service. So this guy, if I jump back over to my camera here, has a bunch of services. This one device has a single hardware MAC address, right? So just like Ethernet boards have MAC addresses, BLE devices have a MAC address, right? And they should sort of be globally unique, although I don't know that I would trust that necessarily, but they should at least be locally unique, right, within your space, right? So this guy's going to have some MAC address that got burned into it from the hardware manufacturer. But then it has a bunch of services that it offers. It offers a temperature sensor service. It offers humidity service, accelerometer service, magnetometer service, a bunch of other services on there, a button service. Now, some of those services are totally made up, right? So there may not be well-known services pre-documented in the BLE protocol or specification for those. There are some, however, that are. So this one also will tell you, back over here, notice it's got a battery on it. It has a battery service that can tell you sort of what its battery, come on, focus, what its battery load is. Okay, it's just not going to focus for me. Well, you get the point. There's a battery in there when we come back. There's a battery in there. So anyhow, the BLE specification actually has some well-known services. Battery service is one of them. And so the well-known services have a GUID that is pre-specified, and you can go ask a device, hey, do you have that services GUID? And if so, it has battery service, and you can talk to it, understanding what a battery service is. On the other hand, you can also create your own custom services and profiles. And so this is an example. TI just made up this F000XXXX dash yada, yada, yada GUID as sort of the ID for a string of their services. And these XXXX values get traded out. So notice down here, there's this AA01, and that, if you added AA01 in there for the X's, that would be the GUID for the IR temperature data. And it's out of there that you would actually read the device and ambient temperature data coming out of there. Cool. And so there's this whole configuration that you'll have to go get the documentation for your device to figure out, what you can get. Now, you can also write values. So for example, on the back of this sensor tag, there's some LEDs and a buzzer. And so I can send messages to it and tell it, turn your LED on, or turn your buzzer on, or turn them off, right? And so I can also send data down to this guy if I want to. So you'll need to read the documentation on your devices to find out what's available and what you need to send back and forth for those. So I had this sort of build out. I'm going to jump over that really quick. So all of those GUIDs and stuff are going to be documented for you in the configuration file. So let me jump back over here to code, and I'll pull this BLE gateway config up. And so you'll notice in here, I have a couple of things. So first of all, I've pulled in a module that knows how to talk. This is the library that does BLE, and it's the shared object on Linux, right? So that's that file. That's the BLE library that implements this module. I'm calling it sensor tag. okay, because it's talking to a sensor tag. And I'm going to tell it that this instance specifically is looking for this MAC address. And I did my work ahead of time and went out and found out that that's the MAC address for that sensor tag you've seen me showing on the camera over there. That is its actual sensor tag. And then remember all these GUIDs and stuff. So we tell it, hey, one time when you start up and start communicating with that, we want you to read the value from this GUID. Notice that one doesn't start with F00. This is one of those well-known ones. So these guys are things like, what's the manufacturer name? What's the serial number? What's the model number? What's the firmware revision? You know, that kind of stuff. So these are all just well-known values that any BLE device can publish. And so we're going to go and attempt to read those just once at startup, and it'll regurgitate them out to the screen. We're also, however, going to come in and write to this value a string that tells it to turn on the temperature sensor. And you can read the documentation as to why AQ equal means turns on. It's really just a base 64 encoded string. And in fact, if I were to go, I should have pulled this page up earlier. Let me see if I can get that up here really quick. ASCII hex, I think that's the one I use. Yeah, this is kind of a easy site to go use, but if I go paste into the base 64 that value and say convert, so there's that AQ00. Come on, convert for me. Notice that the binary is really 1. So that base 64 string really means 1, and that 1 means turn on the temperature sensor. And how do I know it's the temperature sensor? Well, you'd have to go read the documentation to find out that that GUID on the CI or the TI sensor tag means, you know, the temperature sensor control on or off, right? And then we'll similarly write to that same thing one time at exit. So if you cleanly shut your gateway down, we're going to send it AA equals 0, or AA is the string. And I bet if you guessed, you'd guess that was all zeros. So if I paste that in and convert it, sure enough, that's going to be just binary 0. Right, so that turns that temperature sensor back off for me. Otherwise, what we're going to do is periodically, while the gateway is running, every 1 second, we're going to read the value. Remember that AA01 I said was the temperature data. So here's the rub. That temperature data, if I were to go back to my slides, notice is a complex value. It's the devices, the objects, temperature in 2 bytes, the least significant bit or byte and the most significant byte, and then also the ambient temperature, least significant byte and ambient or most significant byte. So you get these 4 bytes shipped up to you, and then it's up to you to sort of parse those values out. And I'm not doing anything to parse those right now. So we're going to see the data come up, but it's going to be a little bit ugly. So, but we'll see it. Okay, so let me jump back over here. We've seen the config. All the other stuff is pretty much what we expect. It's just that now my mapper says when you see messages from this MAC address, map them up to this device ID up in Azure. So if I go back to my portal, into the Edge IoT, down to my device IDs, you'll notice that I have one called Sensor Tag 02. It'll load up here for me. Cool. So it's going to send up as this device. So that's the one I'll want to monitor. Cool. All right, so let's go back here to the thing here. We'll get out of this one. Cool. And I'm going to change over instead to the BLE gateway sample. And so again, there's a log.txt in there. We'll get rid of that. I guess I'm not looking at these log files, so I don't really need to. And I'm going to tell it to go run the BLE gateway using that BLE gateway JSON file that we were just taking a look at. And so this guy's running, and you'll notice that it's not actually sending any data yet. The reason why is that on the side of this guy, I have to turn on this little button to tell it to start publishing. And as soon as I push that button, a bunch of stuff scrolled by here. Let me go ahead and just exit out here so we can see what happened at the top of this. But if I scroll back up, remember those read once at the beginnings that we saw? That's these values that are coming out. So it's going and getting the serial number and firmware revision and hardware revision. Remember, I said this is a TI sensor tag. So some of these had values in them, some of them didn't. It just kind of depended on what TI decided to stick in there and actually have this device publish out. But I can see at least that it was from Texas Instruments. And then it actually started reading temperature values. So ignore these errors here for a little bit. But down here, pardon the errors. Okay, there we go. It eventually actually started reading temperatures. And remember, there was the device or the ambient temperature and then the device temperature. So this is kind of like how hot is the board, and then this is how hot is the air around the board, right? And so here it's been parsing that data out for me, but that's not what's actually getting shipped up to the cloud. So let me start this guy again. And then the first thing I was mentioning is that this thing to save its battery will stop publishing data for a while if nobody's talking to it. And so the way that you start it is push that little button on the side, and then while it's sitting there in unconnected state, you can see this little green LED flashing. And that's basically saying, hey, I'm advertising myself. Somebody can come connect to me and start pulling my data down. And so if I come back here and tell this guy start back up again, it goes. As soon as it did that, the green LED goes away. Now, I'm getting a different situation right now, and I'll explain that in a little bit. But these flashing things were there for a little bit. Notice now they just went away, okay? And I'll explain why that's happening coming up here in a little bit. But I have a couple of functions in Azure that are sending messages back down to this device and telling it to do stuff. And that's why those lights were behaving weirdly there. So we'll see that. That's also what these messages are that are coming back. And they look like errors, but you'll see that it says it's not a failure since it's optional. So these are really more just warning messages that are coming back. Anytime that the hub sees a message coming back down to the device, the AMQP libraries generate these little warnings. And so they just get emitted into the string there. But here's the actual temperature, right? And so I can see the ambient temperature right here is coming back at, 19 something. Sorry, it keeps moving on me, 19 something. And so if I were to come back over here to the camera, I'm just going to hold this in my hand. And if you watch that number down there, notice we went to 29, make it hotter, 35, 30, 32, and if I take my hand back off, it went all the way up to 50, it's cooling back down, right? So that's real temperature data coming off of that sensor, those numbers that were flying back there. Now, if I jump up to the cloud and look at that sensor data, remember I said it wasn't going to be pretty? This is what I mean by not pretty. This is those values coming back. And those tool here is trying to show them as character data. It's not characters, it's bytes that mean temperature data. And so it's just funky looking characters, right? And so what I would want to do in this case is add another module down here on the gateway side that would parse that data and generate a nicer message. And this is where I have to admit a failure on my part. There is the documentation has a module to help you do that. And it's in here. So there's a use the gateway for data conversion. And this one adds a module in that will go in and parse that data out nicely for you. But while I was setting on my NUC today, I just could not get that module to compile. So I'll show you the result of so basically it would have converted those things into a much nicer looking message that looks like that. That's basically, if you imagine that, that's what we would be seeing here instead of those funky characters coming back trying to represent that temperature data. Cool. So the downside of that is that the other thing this module does is it looks at that temperature value and decides if that temperature is greater than some threshold, 30 degrees by default, it's going to add a property to this message called temperature alert and set it equal to true. And so the other cool thing then is I can come in here into my IoT hub and set up what's called a route. And so, in fact, if I go over here, notice I've set up another intermediate event hub called Edge Alerts. So this is just another message queue that can hold temperature alert messages. And so this guy, I can set up a route on it that says, hey, if you get a message from the device where the temperature alert was true, send those messages off to that alert hub that we had over there. And then the last piece there is that I can set up some code that runs in Azure that gets triggered automatically when that alert happens and sends a message back down to that sensor tag. And remember those big ugly GUIDs for, like, writing things? Well, this one turns on the red LED, and we send it AQ equal. Remember, that was 1 binary, so that turns on the red LED. And then I have another function that runs just periodically. Oops, sorry, wrong one. This other one runs periodically just every 10 seconds to turn that alarm back off so that I can clear it. So just to show you what that function would do, let me get my camera up here. And so I've got the gateway still running. It needs to be there to support that communication. And let me pull this over here. And come on. Cool. All right. Well, there it is. And so over here, I'm going to tell this one to go ahead and run. All right. And notice as soon as I did that, that red LED came on here. Now, shortly, the red LED is going to turn back off. And so the reason that red LED turned back off is because that other function is running every 10 seconds and sending it the turn off message, right? So I can hit run here again. We see the LED come on, and then the other function ran right then. It's just every 10 seconds. So it depends on when I caught it as to whether or not, how long it takes to turn it back off. But there's the red LED. And then within 10 seconds, it gets the off message again. Right. So that's basically kind of communicating back down channels. So that's kind of cool. At this point now, I'm able to get messages from the device up to the cloud and the messages from the cloud back down to the device. So that's pretty neat. Cool. Well, so with that, we talked through pretty much Azure IoT Edge v1 and sort of talked about how that all works. With Azure IoT Edge v2, let me just pull this up here really quick. We have all those modules. The core idea is the same. We're going to have the underlying gateway SDK or gateway runtime, and it's going to use messaging. But the cool thing is it's going to use the same messaging APIs as IoT Hub itself, or API. So it basically acts kind of like a local IoT Hub, and it itself runs in Docker. Your modules then also are just going to be Docker containers. So this whole ANSI C99 code that we did for cross-platform compatibility goes away because we're now using Docker as a way to wrap up our code and run it on multiple platforms. And then the modules just communicate with the gateway itself using this sort of modified IoT Hub gateway SDK there. So the cool thing is that those modules now can be pre-configured and living up in the cloud in a repository or like some, pardon me, down here, some repo, some container registry. And so in Azure, that might be an Azure registry, or it could be the Docker Hub, or wherever you want it to be. I can have modules sitting up there, and I can set up my configuration of the gateway in the cloud. It'll pull that configuration down and then find the modules it's supposed to run, download them from the cloud, and actually set them up. So all of that local JSON configuration stuff starts to go away with that. And notice it can even include things like machine learning, stream analytics, and Azure functions and things like that. Those are some of the pre-built modules that they're hoping to include here with V2. And again, I'll just sort of learn with you how much they actually get put into the public preview. So looking forward to that. All right. So with that, again, time-wise, we'll wrap it up here, but we talked about the Azure IoT Stack. We looked at sort of how Azure IoT Edge v1 works, and then a brief little sort of here's what's coming in Azure IoT Edge v2. So thank you very much for your time. Again, over in the chat window there, there's a link off to the slides, and I'll jump back to the chat and share my screen if anybody needs to hang out here for a little bit and ask any questions. But otherwise, thank you very much for your time, folks. Small box name. Okay, the sensor tag. Yeah, they're cool little boards. Like I say, you can actually write code for them, which is neat. If you want to get the dev kit for it, you can actually deploy code down to them, and you can create your own custom implementation. But it does ship with a default implementation that just sends all that sensor data out using those GUIDs that we were talking about over BLE. So that's cool stuff. Yeah, we're talking about last mile stuff. Yeah, definitely the gateway devices we want closer. We want them as close to the field device, the sensors and the actuators and the microcontrollers that are, at the quote unquote device level, as we can possibly get them. And so but far enough away that they have a benefit, right? So, for example, if I had devices sitting in a field, literally like in a agricultural field, and communicating using some RF technology, there's no reason for the gateway to be immediately adjacent to it. It just has to be within communication range. But it's then going to tie into a higher bandwidth connection, typically. If nothing else, it might be GSM or something like that, but it at that point could be Ethernet or satellite uplink, or I don't know, whatever else may be going on in the back end for that communication then. Questions on the NUC versioning, and I apologize, I'm not an Intel guy, so I'm not positive on the versions of the NUC. Installing the Azure SDK. I will give you this one. So this is a camp we ran around the NUCs with Azure. So it's aka.ms, Microsoft Intel IoT camp. So that'll take you to, I just put that chat, if you're still in there, that'll take you off to a zip file, that's a whole hands-on lab that sort of walks through some setup. It's actually just a release out of a repo, which is up at github.com, DX camps, same thing, Microsoft Intel IoT camp. Let me jump back here. Advantage of running Ubuntu. I'll tell you what, I have much better luck with Ubuntu, but that's also just because I know it better. The Wind River stuff is perfectly fine. I'm just not as familiar with it. So when it comes to installing packages and things like that, I'm using their Smart Installer versus apt-get, and so I sort of have a little bit of an impedance mismatch with the Wind River stuff, just because of my own ignorance. So for me, I prefer Ubuntu, but again, that's just because I haven't had the time to learn Wind River better. Oh, sorry, thanks. I got the aka.ms wrong here. Let me go pull it up here and make sure it's right. So HTTP, aka.ms, Microsoft, Intel, IoT. Oh, I'm getting a period in there for some reason. Intel, IoT camp. There should not be a period in it. Cool. Yeah, that's here. I got it right. So let me get back to the chat window here. That'll take you. That one takes you to the repo, and that looks like somebody else. Thank you. Posted the link up to the GitHub part there. So those are things that you could use that are specific to that NUC with the Grove Shield and the Arduino and stuff like that, but that may help you get around some issues there. Let me scroll back up though. You had this question though. So what's the use case of Edge? So again, the question was. Sorry if I missed it. Is there a cost for the Azure IoT Edge product? No. So that's really cool. And that was a concern that I had with V2. So I'm hoping to find with V2 what the pricing information will be. I don't know if they've released that yet. V1, no, it's open source. It's an SDK sitting up there in GitHub. My hope is that we'll see similar pricing on the V2 gateway as well there. So, but as is right now, nope, go for it. It's free. CPU processing requirements for Edge is going to depend on what you do on it, right? So I mentioned that you'll have the ability, and you can do it now. It's what are you going to do in those modules? Right, that's really it. What kind of data volume are you expecting to pull through, and what are your modules going to do with that data? So it's one of those unfortunate computer industry answers of it depends, and it really does. From a bare minimum perspective, you could conceivably run this on something like a Raspberry Pi Zero. If all you're doing is proxying a low volume of messages up, it could handle it. But as you start looking at wanting to cut latency down, so we want to reduce as much as possible, just even code execution time. But also, are we deploying machine learning models down there? Are we doing stream analytics, or are we running complex code, et cetera? Then those CPU requirements are going to go up with that. Yep. Unfortunately, normal computer architecture stuff, I can't tell you how big of a box you're going to need. You're going to have to sort of go out and do some field testing with that and get a feel for what you're doing. So the role of Microsoft IoT Core with IoT Hub right now is, with IoT Hub, it could just be another device, right? So IoT Core addresses the operating system at the device end. right? IoT Core right now is not a viable runtime for gateway just because of the way the gateway itself runs, right? So with IoT Core, you're constrained to creating UWP applications, whereas the gateway, let's just say V2, because that's really probably where you would start deving, is going to be Docker, right? So that's a totally different environment, and IoT Core is not going to play in that game right now. So IoT Core then, its role then would be to implement the device side of things. And if you were to think about an enterprise scenario where I wanted to have a little more enterprise control over the operating system running on the devices, then IoT Core is a great choice for that because it's Windows, and you get all that same sort of device management that we're used to with, tablets and laptops, and if you had Windows phones in your organization and all that kind of stuff. So it's a fantastic story for that. But for the we have .NET SDKs or Node SDKs or whatever that you can use in IoT Core to communicate with an IoT hub on the back end. Perfectly happy. Tons of samples on that to be able to do that. So it can't be the gateway device right now, at least not using this gateway solution. All right, folks. Well, thank you again very much for your time. Hope you got something out of it, and we'll see you at the next DevFest. Take care.